Welcome everyone to the KubeVirt Deep Dive Bird of a Feather session. Just a quick check, who was here for the intro session earlier today? Very good, welcome back. I won't ask the same questions that I did then about who's running Kubernetes and who has existing virtualization infrastructures there. My name is Scott Collier. Again, I work for Red Hat, and I focus on basically the the KubeVirt upstream community side of this. And we have David Vossel here from Red Hat as well, focuses on virtualization, Ben Warren from Cisco, and Adam from Red Hat as well. So we're going to take a little bit of a different approach to this one than we did the earlier session. I had some bad time management, and we just didn't leave enough time for questions at the end. So on this one, we have a lot fewer slides. We want to have more questions. We have more T-shirts for folks who ask questions. The first 8 folks get a T-shirt. And we want to really make this an engaging session here. So have a little bit of conversation about architecture, just the core virtualization architecture, the storage architecture, and then Ben's going to cover some of the use cases they're looking at Cisco, and then Q&A time. So just for those who weren't here in the previous session, I'll just cover quickly what KubeVirt is. And it basically just enables Kubernetes to manage virtual machines in a common shared environment alongside your application containers. Okay? It's a drop-in add-on via CRDs, custom resource definitions, to give you a similar look and feel for managing your applications and your virtual machines. Okay? That's it. That's all we'll say on that. And this is like it's kind of a newer slide for me, but it's current capabilities. So without like digressing and going through every single option here, just take a quick review of the categories that we're looking at with compute, performance, networking, and storage. Like the thing that we want you to take away from this is that the developers and the contributors to KubeVirt are quickly enhancing KubeVirt to have the same capabilities that you're familiar with on your other virtualization platforms. It's not all the way there yet. There's still a lot of work that needs to be done. But as you can see, the current feature set looks really robust. And tonight, there's going to be a KubeVirt gathering where we are going to have a chance to talk about the roadmap and some of the features that you don't see here now that we need to look at, developing and prioritizing over the short and midterm. So having said that, David, I'm going to hand it over to you, and let's get started on the virtualization architecture.
Sure. Can you hear me? Oh, all right. So I'm David Vossel. I work at Red Hat. I guess I was already introduced. Kubernetes has done a really great job at giving us extension points that essentially let us develop KubeVirt as if it was just part of the Kubernetes core API. So just like Kubernetes has things like deployments and pods, we can register our own third-party APIs using custom resource definitions. That's the extension point that Kubernetes provides us. In addition to that, we're also using things like mutation and validation webhooks, and even an aggregated API server. And all of these things together let us create an API that really maintains the exact same look and feel as a core Kubernetes API. So from a user perspective, it's going to look really familiar to people, and people that are developing and want to develop against KubeVirt are going to see what we're doing. It's going to make a lot of sense. In addition to extension points, we're using just patterns that we see Kubernetes do. So we're leveraging these patterns that they've already laid out for us. And one of those is this concept of stacking APIs. So in Kubernetes, we have this stacking where a pod is at the bottom of the stack. You have a replica set that's stacked on top of pods, and you have deployments that are stacked on top of replica sets. So there's stacking of deployments to create replica sets, which then create pods. We're doing the same thing in our APIs. So we have a virtual machine instance, which is kind of our equivalent of a pod. It represents an instance of a virtual machine. And then layered on top of that, we have higher level APIs that manage things like virtual machine replication and stateful persistent virtual machines that you can turn off and on, and they maintain their state. So the whole point about this is users can interact with KubeVirt using the standard tooling that they're used to with Kubernetes, and it's going to be familiar to everyone. Looking at the back end, what we have is we have a set of controllers that we have implemented that implement our APIs and coordinate the virtual machine launch flow. So when you post a virtual machine instance to the cluster, our controller is going to observe the creation of that object within the cluster, and in response, it's going to generate a pod for that virtual machine to live in. That pod, if you have, let's say in your virtual machine instance spec, you have a specific network, you have some persistent volume claims or resource request limits or something like that assigned to it, that pod's going to have those resources attached to it. So when the virtual machine is scheduled, if you said you wanted a 4-core virtual machine with 10 gigabytes of memory and a PVC with a virtual machine disk on it, that pod's going to actually have all those resources attached to it. And when the pod starts up and it's been scheduled, we have a component inside of that pod which coordinates mapping those resources that we've attached to the pod to the virtual machine process that's being launched within the pod. And the end result here is that we have a virtual machine process that's kind of assumed the role of the pod, and it really just kind of looks like the pod at that point. And to kind of drive that home, our default networking, if you ping the pod IP address for the virtual machine instance, you're getting a response from the virtual machine guest and not the pod exactly. So from a 10,000-foot view, that's our architecture. We have APIs being registered as custom resource definitions and a set of controllers that implement those APIs and launch virtual machines within pods. I guess we're going to hand it over to Adam. Is that next for storage?
Thanks, David.
Thanks.
And yeah, I know it's being recorded, so maybe hang out on the stage.
Okay. Yep. Okay, it's still on. So basically, when we get to storage, we want to continue that theme of a native Kubernetes experience for virtualization. So a couple of design decisions that we made early on when we thought about how to give persistent storage to virtual machines was the first one being that when you think of a VM disk, you should think of a PVC. It's a really handy API point within Kubernetes that we can use. So basically what we chose to do is that a single PVC maps to a single virtual machine disk. So if you want 2 disks with your VM, you could have 2 PVCs. This allows us to take advantage of all of the work that's going on in the Kubernetes SIG storage to provide things like snapshots and cloning and all these other things that we'll just be able to get for free for our VM disks. Another thing, and so basically how this works is on a PVC, it started off that we just had file mode PVCs. In that case, we just create a file on the root of that volume that uses all the space of the PVC in order to put the virtual machine disk. And then KubeVirt knows how to map that into the configuration to launch the VM. When it comes to block mode PVs, which is something that's coming up, we can do the same thing, except in that case, we just expose that block device directly to the virtual machine when it launches. So this really gives us a nice integration with the base Kubernetes storage. Another design decision that we made was that we would use raw image format instead of something like QCOW2, for those of you familiar with that detail. And the reason is we really wanted to push all of the brains and the smarts of the storage down to the storage providers. And we want KubeVirt to work with any storage that you bring to the table. So whether it be Gluster or local storage or cloud provider storage, it doesn't matter, because we abstract at the PVC layer. So this means we won't be doing software-defined storage things like implementing, it's a nightmare that haunts me from the past, live deletion of snapshots using QCOW2 image and like the QEMU and libvirt APIs. We assume that the storage will take care of all that for you. So that's basically, I guess, an overview of that. Then there was a unique problem when it comes to persistent storage for virtual machines. So normally when you think of something like a database, the database or the application that's using the storage is kind of generating the data, and you want to save it over time. But with a virtual machine, you kind of have to start with something. You need that disk, and you might want to have an operating system preloaded on that, for example. So then the obvious question comes, how do we get that data into the PVC before we hand it off to the virtual machine? So in order to solve this problem, we also wanted to use a general purpose solution. And we kind of thought of 3 different ways that you could get data into that PVC in a general purpose way. One would be what we're calling import, which is that the cluster pulls that image down from a hosted location, such as a web server, like a pre-installed disk image. Another one would be that you would want to push that or upload it from your local machine. Let's say you prepared a disk image, and then you want to push it up into the cluster into a PVC. So we call that our upload method. And then the third way would be to actually clone between from an existing volume. So for example, I have a virtual machine template with a prepared disk image ready to go, and I just want to copy that multiple places. So in order to satisfy these 3 use cases, we started developing something called the Containerized Data Importer, and it's a project that's hosted under the KubeVirt GitHub org, but it's really independent in that it can be used for other use cases, just general generic importing of tar archives, for example. But so we're developing this in order to kind of solve that problem. Some other things we're working on in storage are development of things that virtualization really benefits from in storage, like having the provisioners do cloning. We're participating with the group developing the snapshot capability, kind of pushing these things into the CSI spec. And also things like moving storage between namespaces. So you might want to prepare golden images for your virtual machine disks in one namespace and then transfer it to your user's namespace. So a few different things like that. And I think that's enough talking, because if you have more questions, we can answer the specific ones that you have.
Thanks, Adam. So that'll go to Ben. I'm just going to swap my display here real quick and hand it over to Ben from Cisco.
Hello?
Oh. Looks like GNOME shell crashed. There we go. Try one more time. You see? Sorry, folks. Let me just...
I can work with a thumbnail if you can get that going again.
Okay. Yeah, it's actually not letting me apply anything right now. Hang on just a second. Let me try to... Yeah, as a matter of fact, that's actually good. Again, Joe, you hand out the T-shirts, and all questions are welcome. And then we'll get it over to Ben in just a second. So, yeah, go ahead.
Content is currently supporting 9P for exporting PVs to either VM. Do you have any plans to support having a PV with data in it, not as an image, be able to be exported into VM?
Yes, we've actually...
Repeat the question.
Yeah, so the question is, have we looked into using 9P to export basically a file system directly into the virtual machine? It's something that we've talked about, not something that we've pursued directly. I think it would definitely be pretty doable, as the architecture should allow for that to happen if there is interest in it. Oh, you're good? Okay.
Okay, sorry about that. It looks like we're back up and running. So, Ben, go ahead.
Sure. Okay, so my name's Ben. I work in the Compute and Distributed Storage group at Cisco. I'm going to talk a little bit about an engineering project. This is something that doesn't have a name or release date or anything like that, so it's really just things we're playing around with. So Cisco's a pretty major vendor of HCI. We sell a lot of servers that have very powerful networking, as you would expect from Cisco. We have a product called HyperFlex Distributed Storage that operates on UCS as a software product. And we have a cloud-based management system called Intersight that is used for managing resources, UCS servers, and we're moving into a lot of other Cisco's hardware. But we also ship a lot of virtualized appliances for many of our different business groups across the range that generally ship as an OVA that customers would slurp into vCenter or whatever. And so we're looking at ways of bringing these together into what we call an appliance deployment platform. Here's a diagram. So we have a cluster, a compute cluster that's a compute and storage cluster of 3 UCS servers sharing the distributed storage, HyperFlex distributed storage, and we have multiple appliance VMs running on these servers. And we're using KubeVirt for the VM whatever, orchestration, I guess you could say. Fairly simple diagram. Hopefully it's clear. Feel free to ask questions if you have them. And so we found this to be a pretty good system. So the things that were important to us is we need to have very configurable networking and storage. So we're using CNI. These different appliances have very different networking needs, as you can imagine. Generally, multiple interfaces is a biggie. So we've been using Multis and then the various, either or Bridge or any of the CNI plugins that are available out there to provide multiple interfaces to our VMs. We're also using CSI plugin for our HyperFlex to do the storage plugin stuff. We have a lot. We need to be able to import a variety of different types of images. So the CDI is a very cool project that we have just started playing around with, but it looks like it will be a winner for what we want to do. Things that when we're talking about an HA or a compute cluster here, so one of the reasons we really like Kubernetes, not just because it's trendy, but I mean it has the idea of HA. So we like the idea of if a VM goes down, it will quickly spin up somewhere else, or even better, it will memory coherently move over without glitching on another node. So we like to see like fast failure detection within Kubernetes and KubeVirt and the live migration. These are things that we're looking forward to. These things are getting better every day. And the last thing that's important to us is VM configurability. There's always trade-offs in a project like this where you're trying to stick with the Kubernetes way of doing things, or you're trying to bring SRIOV, whatever, or some type of hardware pass-through into your VM, and how are you going to do that? And so we're looking at ways, it's important to us to be able to change pretty much anything. Even down to QEMU command line, because libvirt doesn't even necessarily support any of the new things as they come into QEMU. I've worked on some QEMU features that never made their way into libvirt, but I might want to exercise them, so I'd like to be able to do that with KubeVirt. And that's all I have.
Thanks, Ben. Okay, so let's go into Q&A session. I've got a question for the Virt team, just to kind of get this started. So what are the options that we have for VM replication right now?
So we do have a higher level controller called Virtual Machine, Virtual Machine Instance Replica Set, I believe is what we've called it. It works similar to a replica set in Kubernetes, and it's going to allow us to scale out as many virtual machines as we want. We're also investigating ways to reuse the things like deployments and replica sets within Kubernetes to launch virtual machines and have that seamlessly work in KubeVirt. So you would define your virtual machine instance and actually have a deployment somehow manage replicating that. So that's kind of future things that we're looking at. Right now, we have a virtual machine instance replica set, though, that lets us do a lot of the things that Replica Set does with pods.
Thanks, David. And one question for the storage team. So how would someone build a repository of disk images similar to AWS AMIs using KubeVirt?
Yeah, right. So basically, we support in CDI, being able to import QCOW2 or raw images. They can be compressed if, in the case of raw. So if you had, for example, a library of in-house images that you wanted to produce virtual machines from, one easy way to do would be to just host those up on an internal web server that's local to the cluster or quickly accessible via the cluster. You can use CDI then to import those images into your PVCs associated with your VMs in a declarative way. So you can just maintain that in that way if you like.
Hey, I have one question.
Sure.
Can you pass like custom user data when we boot up the machine?
So the question was, can you pass in custom user data when you boot up the machine? David?
Like cloud? Are you talking about CloudNet? Yeah.
Yeah.
So yeah, you can do that inline in the virtual machine instance spec. You can actually define the CloudNet data. You can also do it through like a secret or something like that. You can define the CloudNet data in a secret and then map it to the virtual machine instance.
Yes, sir.
I have a question about the CDI. Do I understand it correctly? So this is kind of a step in the binding process. So when you see a new PVC, you bind the image, you start this container whose sole purpose is, or this pod whose sole purpose is to basically download the image and populate the PV, which then will be bound to that PVC, and then the actual virtual machine will start in a different container.
Yeah, so the question is a little bit more about the process of how CDI works. And so, yeah, you have it exactly right. The way that it works today is that when you define a PVC in the cluster, you use an annotation, and that annotation is recognized by the CDI controller, which is running in the infrastructure. And based on what you have set in the annotation, it will spawn a pod that attaches to the PVC, performs the work. It'll annotate the PVC afterwards to indicate the status. And this is a good time to kind of, as some of you might be thinking, how do you synchronize the process of I want this data to be in that virtual or in that PVC prior to the VM starting, because if you just declare this stuff together, the ordering's not guaranteed. So for that, we actually have something called data volume, and it's an abstraction on top of the PVC, but everything is still using the PVCs. And what happens is KubeVirt integrates with a data volume object. You create this, and the data volume controller will actually create the PVC and manage the preparation of it, and KubeVirt will not start the virtual machine until the process is completed. So it's all managed in a declarative, orchestrated fashion.
Thanks. Okay, over here.
I'll stand with you.
Sure.
So it's a two-part question, I guess. The first part is, one interesting thing about this fascinating implementation is that we're kind of reintroducing lifecycle management back to this world of orchestration, right? Which is not a bad thing because it's something that we do need in the virtual machine space, which we don't kind of need in containers. It was mentioned before that we're thinking of maybe creating a Kubernetes operator that could help kind of manage this life cycle in kind of standard ways that we know: install, configure, replicate, stop, start, etc. The second part, if we really solve that life cycle management issue in a way that we're all familiar with, there's a kind of golden ticket here that would be to support, say, existing legacy applications for OpenStack that use heat templates, the hot language with Mistral workflows. If you could take, for example, a heat template of an existing legacy application and actually have it run with this system with KubeVirt, say with this Kubernetes operator that does the lifecycle management, wow, that would solve a lot of problems for many of us.
I guess I can respond to that. That's a lot. So heat templates, we would have to come up with some, I don't know a whole lot about heat templates, but I know that there would have to be some sort of mapping of what you define a heat template, which could be maybe an auto-scale group or something like that, to a Kubernetes deployment or replica set of some sort. We could investigate something like that. That might be interesting. We're accepting patches. If you're interested in prototyping something like that, that'd be interesting.
Sure. 10 minutes. So right here, you've had your hand up a few times.
So what exists today with KubeVirt as far as feedback
It's the same thing as.
So just repeat the
Okay.
question. So,
We talked a lot about how it gets built out when, the controllers deploy the VMs and set everything up. What about, when the systems go down, what kind of feedback loops to this?
It's similar to what you would expect in Kubernetes. So if you have a deployment and you say you want 3 replicas, and if one of those goes down, then it's going to bring one back up. So when we have a virtual machine instance replicas, yeah, it brings it back up. We're also looking at things. Well, it's a little bit different in that we're talking about mortal workloads versus immortal workloads. Whether a pod is a mortal workload, once it's gone, it's gone. Where a virtual machine, we think of that as more of a persistent workload a lot of times. So there are some HA considerations where things like if you're vacuuming a node, you might want to live migrate those resources away, or if it fails, you might want to bring it back up with the exact same storage, similar to like a stateful set. Yeah.
yes, sir.
So you see the live migration concept getting implemented as part of like a drain. So if we were to go in and operationally drain a node, it would be able to then do a stateful live migration, memory intact.
So the question is, if you're evacuating or draining a node, if we'd be able to use the live migration as a way to evacuate that. And absolutely, we're looking at that now. That's a important use case because it lets you, do hardware maintenance without having to actually kill stateful processes. Yeah.
Thank you. Go ahead.
So related to live migration, you said you're using CNI IP addresses. They're bound to nodes. How does that work?
Right.
So
The question is, with live migration, CNI is, when you start a pod, it gets a unique IP address. And if you're going to live migrate between 2 pods, that means that IP address isn't following it. You have 2 IP addresses at that point. So when you live migrate, you're migrating to an environment that has a separate interface. We haven't solved that yet. We're looking at other options for networking that would be specific for people that need that type of failover. There's possible that there's use cases where people might be okay with not carrying over their IP address, but they still want to have that stateful application migrate as well.
I mean, to that effect, in our situation, we're using Multis, and our second interface would be a bridge plugin. So if you can specify the MAC address when you define the VM, then it just works. As long as your corporate infrastructure manages DHCP or whatever.
Okay, sir.
Kind of 2 questions. So first, are those the integrations you support right now, AWS, GCP, cloud providers? Or is the interface more extensible? Or?
These are simply, these are just getting started like proof of concept environments. So if you go to the KubeVirt website, we basically build out like AMIs and images for GCP that just lower the barrier to enter for you to kick the tires on this. We aren't suggesting that you actually run your KubeVirt infrastructure on top of this. In fact, it would probably be leaning more towards the bare metal deployment scenario.
Okay, because my developers, they like to every once in a while get an ephemeral virtual machine, but they want to continue to use the Kubernetes API. And sometimes, I don't usually want to give them the AWS CLI or the G-Cloud CLI. I just like to say, create a virtual machine resource in Kubernetes, and it'll come up for you, and it'll select the right cloud.
Right.
Are you saying that's not something KubeVirt can do right now, or that's something you'd like to do in the future? Is that integration you would be interested in?
The question is running virtual machines on top of the public cloud. Is that? Well, the problem with that is nested virtualization. So like GCP, I believe, uses KVM, and it might let us do nested virtualization, which means that you'd have the same performance. You can run KubeVirt emulation mode on AWS today, and it's just not going to be performant. So
That's what we do.
I was more thinking, can you actually just provision the VMs in EC2? So not nested virtualization.
Oh.
Did you understand the question?
Well, if I understand it correctly, he's saying, can KubeVirt call the AWS API to launch a VM and manage that?
Yeah.
Yeah, instead
No.
of like libvirt.
I mean, there's cluster providers for that, and Kubernetes that spin up nodes and things like that.
But it's a pod or a Kubernetes node agent, not a VM as the first class that is in your API is targeted.
Yeah, I see what you're getting at, but we don't do that.
Would you consider it?
Bring it up in the mailing list.
perhaps. Go ahead, sir.
Question. So we've been struggling a lot with getting the new Windows stuff that's coming to Kubernetes as a whole, and it sounds like KubeVirt might be a solution to kind of solve that headache for us instead of having hybrid clusters. So can KubeVirt run a Windows VM?
So the question is, can KubeVirt run a Windows VM? Yes, we're targeting Windows.
Targeting or can?
I believe it can at this point, yes.
Yeah, we actually demoed that last year at Red Hat Summit, running Windows VMs under CNV and
Yeah.
KubeVirt.
That's a big use case for us.
Yeah. Okay, Steve, how much more time? A couple of minutes? 4 more minutes? How many more questions do we have? Go ahead.
So you mentioned the operator, right? One of the biggest problems with VMs versus containers is the fact that a container is already everything packaged already, right? You have your application, everything fine. However, in a VM, in some instances, if you're using like, you're coming from legacy, you might have like Ansible, Chef, etc. Like in a operator model, would that be a way to like, what would be the best way to kick off that setup of the application? Like deploy the VM and then have the operator like kick off a Ansible job to kick that off, or what would you recommend to get that application set up?
Well, if you already have this, the question is, I don't know how to summarize that question at this point. The question was about how to provision virtual machines, legacy virtual machines, I believe. And my assumption is that if somebody has a legacy virtual machine, they already have a system in place for provisioning them. I think you would use the existing system that you have, or else you're inventing something new. So if you were using Ansible, wouldn't we just kick off Ansible to provision?
That's my question, right? So like, would an operator kick that off? Because like, what is the point of having, like, to your point, right? Like if you already have all of this, then why would you want to reinvent the wheel and kick it off in KubeVirt, right? So to me, the way I see it is KubeVirt gives you that single interface for you to provision VMs and do all of these things in a single interface, as opposed to you have to manage VMs now through something else, and then that's.
So you're getting infrastructure convergence, where your containers and virtual machines can live next to each other. It's on you or whatever to implement how to provision those virtual machines, and whatever makes the most sense when you migrate those virtual machines to KubeVirt.
Okay, one more. Go ahead.
Multi-tenancy, how much thought has been put into users not having very much privilege versus the sysadmins that set up Kubernetes do? How much privilege do they have to launch a VM?
So you have to have privileges to create. The question was, what privileges do you need to start a virtual machine? You have to have the privileges to create and modify virtual machine instance objects, and that's it. And the controller will create the virtual machine pods on the user's behalf. We think about separation between users and cluster admins, though. So something like a migration action would be something that we're thinking might be reserved for the admin, versus creation of a virtual machine would be a privilege that would be for users. So there is some separation, and that can all RBAC. You can all be defined in RBAC.
Do the VMs run as the user's service accounts or as the KubeVirt service accounts?
You can actually assign your own service accounts to the virtual machines. So it can run as any service account that you have permissions, I guess, to use.
Does it need root privilege to launch the VM, or would it be less than that?
I don't believe we need root privilege to launch the VM. I believe that's something that's required by OpenShift, that we can't have root privilege. Right.
Okay, so Steve, our timekeeper, has said cut it off. Thank you, everyone, for joining. Just as a reminder, there's a demo at the booth tomorrow, the Red Hat booth at 8:30 a.m. And then tonight, there's going to be a KubeVirt gathering at 6:45. at the Sheraton on the second floor in the Aspen room. So thank you, everybody, for attending.